Greetings, everybody. This is Sowmya Myneni. I'm the leader of the security analytics team here at LexisNexis Risk Solutions.
Hey everyone, my name is Kushi Kiran and I'm also a part of the security analytics team.
So here today we are with some exciting stuff to share you guys with. It's about Microsoft Fabric and how we can integrate it with HPCC systems for security analytics. So today, a simple view on the agenda is we'll be showing you how you can implement HP systems, deploy HP systems on an APS, and then how we can automate the work units on the HPCC system, and then how we can get alerts when an automation failure happens. And then we'll also go over the components of the Microsoft Fabric, and also we'll take you a tour of the Power BI reporting, the excellent visualization features that the Microsoft Fabric has to offer. So let's take a peek into the security analytics. As I mentioned, as you know, the title also says it, we are doing this for security analytics. But then what is the challenge about security analytics? It is, if you're new to security, then it is an approach for threat detection mitigation. And then it offers a streamlined process to understand the non-compliance information, like if there is any compliance missing, and also to overall improve the organization posture. But then it also involves lots of processing. You have to collect the data across the organization, and that collected data is not going to be small, it's going to be huge. And then you have to aggregate, transform the data, perform correlations on it to make a meaningful sense of that data, which we could say information, right? So we may have to get the valuable information out of that data, raw data, and then validate it against our organization's network infrastructure or the compliance information to get a very good value out of it. So this requires, in order to perform security analytics, basically you will require some monitoring tools. Like say, for instance, you need information to collect about the vulnerabilities associated with your source code, maybe. There are so many open source tools like SonarQube, which can be used to do source code analysis. There are some tools that can give you vulnerability, like even GitHub has Dependabot, which gives information about the vulnerabilities associated with your source code. And then there is some, maybe you have a host intrusion detection system deployed in your organization that collects the vulnerabilities of your workstations or of your servers that have been deployed across your cloud or on-prem servers. So these all involve heavy processing and likewise result in huge volumes of data if you are intending to collect them. That means this huge volumes of data requires a processing machine that will be able to, like a tool that can process these huge volumes of data. And then there comes the HPC systems. It is an open source tool where you can, open source platform to be accurate, and then often known as a big data analytics tool. And then it supports different file formats and perfect for the cybersecurity, huge volumes of data. Then, as we will show soon, it is a very cost-effective setup as well. The reason that being one of the reasons being it being an open source platform, and it is easy to maintain. It is really easy to maintain. You have some issues with it, you just uninstall the Handshot and just redeploy the Handshot. And you can with the making it work with Azure file shares is easy. You just have to make them as persistent volumes, and then it can fit to your needs. Maybe you want HTTPS, maybe you want a self-cert certificate, or you want to use a your organization certificate behind it, or you might want to have a AD authentication based login, or you might want to have it simple like the HT password, Apache HT password kind of authentication. It's up to you. It is customizable to your needs. And then, as I mentioned earlier in the security analytics topic, we need to not only collect this data and aggregate and correlate, but the data becomes valuable when you are performing effective reporting on it, kind of like understanding the details of it, having the teams or the people that are owning those resources, making sure they are aware of those vulnerabilities is an effective way of addressing these. addressing these security issues across our organization. So for that, we need an effective data visualization tool. And here comes Fabric for that. It is easy to share the data with Fabric. And it has Power BI tool that helps with powerful visualization. And you can create alerting names using data activators within Fabric. And one of the coolest features I could say is that it has Copilot. If you have Copilot support on your Fabric workspace, then it supports very good NLP searches as well. So let's see how to implement HPCC systems on Azure Kubernetes servers. Here is a sample architecture diagram that I have we have displayed here. As you can see, on the top left, you can see that there is this resource group that we have created in the HPC Summit Azure subscription. And on the right is the internet available resources like NVD NIST, GitHub repository, and the user over the internet. And then on the left again, we have this primary storage and secondary storage. As you can see, the primary storage is usually connected. It's not really mounted onto the AKS. And the secondary storage is actually mounted onto the AKS for use with HPCC by creating it as a persistent volume on the AKS. And then we have this GitHub OIDC to help authenticate the GitHub CI/CD pipelines to the AKS in order to deploy the cron jobs. And then we also have Azure Key Vault. Azure Key Vault, AKS comes with secrets, right? You can use AKS Kubernetes secrets, but a more secure way, an alternative and more secure way to using Kubernetes secrets is use of the Azure Key Vault. If you install a CSI driver, you set up a CSI driver, then you can seamlessly use the Azure Key Vault instead of the Kubernetes secrets. And they definitely are more secure than the Kubernetes secrets. So here in this picture, you can see on the top left, there is this HPCC Summit resource group, which have all these resources. And the AKS, the HPCC Summit AK has 2 node pools in this example. And then 2 VM skill sets in this example. And one of the VM skill sets, we have HPCC systems running on those VM skill sets as well. And then the ACR, the container registry is connected to that HPCC Summit AKS to dynamically pull the cron jobs images as needed when they are updated from our GitHub pipeline. You can just have from your GitHub pipeline, the AKS can pull those images from the container registry. So how do we automate work units? Before I mention how, you will hear me mentioning NVD NIST throughout this presentation. Like even Kushi will be taking you a tour of the NVD NIST data and how to report on it. But the reason we chose NVD NIST data set for this presentation is we would like to emphasize the importance of the vulnerabilities information that you can obtain from the NVD NIST data. NVD NIST is a vulnerability database, the national vulnerability database that is maintained by NIST. So this data has information about every vulnerability that has been published so far. I believe it's there since 1999. You will find the vulnerabilities from 1999. If you pull all the way back, you will see the start date as 1999, somewhere there. So now that's it. Each vulnerability has some exploitability scope, whether how far it is exploitable. What is the severity associated with? Is it critical? Is it high? You might have always heard about the severity dimension of the vulnerability, but there are so many other dimensions around the vulnerability. Exploitability, whether user interaction is required or not. If a user interaction is required, even though it is critical, but the system is a kind of like a server, then the overall risk of that, overall severity or overall the severity of that vulnerability is much lesser than critical. These are all these factors that are associated with vulnerability that can tell us whether a particular vulnerability is really critical or high or severe to our organization and within our environment. So if you fetch the information of this vulnerability along with this exploit with this score, privileges required, user interaction required or not, you will get an essence of the posture of your organization and the impact of the vulnerabilities within your organization. So it is a very good place to start with. The MVD NIST is a very good place to start with. So in this picture, as you can see, we are showing you a potential workflow that you can use with HP systems in order to collect the data from the MVD NIST and then transform the data to a meaningful extracted information. So on the left, as you can see, in the highlighted red box, you see three components. On the top, you see the MVD NIST, and there is this cron job. And then on the right side of it, there is the primary storage account. So this cron job, you can schedule it to run daily, asking it to collect vulnerabilities from MVD NIST on a daily basis. And you can just collect the last 1 day data, like the last 1 day vulnerabilities that have been published in the last 1 day. And this API endpoint is accessible to everybody. Anybody can create an API token and then start right away with the MVD NIST data point. Now, once you get this data, you want to load it somewhere, right? You want to keep it for long, for analyzing on trends or like going to historical trends, etc. So for that, you keep it in the primary storage account. Let's see how a sample of the MVD NIST data looks like API response. As you can see, there are so many nested items in there. Like for each CVE has this associated published date, lost modified date. Not only that, there are like nested references. Each CV can have multiple references because multiple, sometimes Java Spring might have reported that as severe vulnerability, and some other framework, some other package has reported that as a vulnerability. There could be multiple references coming associated with that severe vulnerability. Likewise, there could be multiple metrics and there could be multiple scoring systems as well. Like for instance, there is CVSS metrics, V4, V3. So V4 is the latest one. V3 is the most commonly used as of now. V2 is like kind of outdated one. So they keep updating their scoring models as well, right? You can see the scoring model, mathematical formula, etc. on their website as well. But this is a sample response. Now, as you can see, if you are using a Python or a simple language and a standalone VM or even AKS to perform it, even though if it is heavier, if this data is small, because you are collecting 1 day, then you might be able to get through transforming that data into meaningful information. But if you're processing loads of data, like from all the way to history, or if it's a different data source, not even NVD, but a different data source, like a different tool within your organization, like a host intrusion system, which has huge amounts of data, the transformation is not going to be easy. You need some assistance with the transformation, which can process all these huge volumes of data. So coming back to the NVD response here, you need some help with transformation, right, for this one. So here we go. You can see that before you begin with transformation here, we have shown highlighted in small phase there, wherein this primary storage is separated from this HPCC landing zone. The HPCC landing zone, as I mentioned earlier, can be mounted, is actually a mounted secondary storage, another Azure file share. It can be another Azure file share that you mount as a secondary mount onto that AKS and is accessible always. Now, on this file share, you will create on this Azure files, you will create a share which can be like you have this DLL, Dolly, and Sasha, and then a landing zone, right? So that landing zone can be given a name as your choice. And then you will have this landing zone where the files from the primary storage are fetched into this landing zone periodically. Or you can design up to your way, but at this point, we are trying to distinguish between the need for longer term storage, which would be primary storage, versus the on-demand storage, kind of like on demand, you need to process some files. The files exist in this landing zone. Once you are done with processing, we just push them back to the primary storage, but you keep the data that is needed to be processed only for the time it needs to be in there in the landing zone. So from here, the landing zone, as you can see, the landing zone activities are on the left, and then the data plane activities on the right. And now once the files are in the landing zone, here is the way the transformation begins. As you can see, there is a cron job on the top of the middle box where the spraying, transform, display are there. So that cron job is the crucial for the automation here. Once the files are in the landing zone, you can have a Python script or any language that you prefer, have a script that that gets triggered, and then look into the landing zone periodically to see if there is any new file. If there is a new file, you pass it through spraying, and once it's sprayed, in the HPCC terminology, basically you are trying to take a huge file and then distribute it to multiple worker units, right? Workers, right? So you spray the file, and then once the sprayed file is ready, you start the transformation of the sprayed file. And then once the sprayed file has been transformed and you extracted meaningful information, that's when you despray it into a CSV format, say, to a format that you want. Despray is kind of like combining all the data from all the workers and putting into one big file again. Spraying splits them into smaller chunks, assigns them to the workers, and then transform is done on those individual worker chunks. And then once the transformation is done, you pick up all those files, combine them all together. Not you really, but the HPC system in the background does that. All the smaller chunks get combined, and the output is in the transformed files as shown in this figure. So let's see how the spraying, how the code for the spraying looks like. So this is a simple spray.ecl. As you can see, you will first check if there are any pending files in that landing zone. If there are any pending files in the landing zone, if it's a JSON format, then you just say, okay, use the spray JSON module. If it's a CSV file, then use the spray delimited CSV spray delimited method, and then you spray into the into those indexes or the logical file names as those logical file names. And once you spread them, you no longer need them in the pending files. You delete that external file. So this is how a simple spraying script can be. So once you have this running and there is a like a Python script, say you have this, for this example, let's take Python script. You have this Python script that can make an API call to the ECL services saying that, okay, trigger this spray.ecl for me now. So that Python script is a cron job that I was referring to earlier that runs periodically and triggers these ECL work units whenever it's triggered. It makes a call to these ECL work units, ECL, asking the ECL work units to be run. It makes a call to the ECL services API. And then that's how the spraying is done. And then comes the transformation. Again, there is another trigger to the transform.ecl file here, wherein once the spraying is done, you can keep tracking the status of that work unit that has been performed or launched by your Python script, say. And once you see a successful completion of that work unit, that's when you trigger the transformation work unit. Now, once the transformation work unit is done, then you trigger the display work unit. So it's kind of like a sequence you have. So if you go back to this transform.ecl script there, you will see that the nested structures of the NVD nest that I showed you earlier are so simply be extracted so very easily, just like you just give the path, like as you can see, source, type, and then you have on the first table on the left, you can see that there is metric, CVSS metric 3.1. That's what you like, trying to extract the nested information into a new data set. And you define for each new nested structure, you create a new data set and extract the data into that data set. And then on the right side, you will see the details of this nested structured extraction, where you normalize the data at the smaller nested structure level and then extract those data into smaller components and then by chunks, and then you combine them all of it into one big when you're transforming. And this, remember, this is applied to all of the workers that are processing your sprayed file. And then comes the display. So once the transformation is done, as I mentioned earlier, the 4 workers that, or 2 workers that you have this transformation happening on, you ask the files to be combined from all of them and have the destination path specified as transform, because that's your share, basically. That's your share name within the, that's the folder name within the landing zone. So that's where you publish the files. And then here, once the transformation is done and the files are the transformed files, you want to move them back to the primary storage, because this secondary storage or the HPCC storage is all for the use by HPCC, and we do not want to use this HPCC storage and primary storage, nor we want the AKS to be mounting the primary storage and running everything on there. There are certain ways, there are certain reasons that you have to segregate these primary storage and secondary storage for the purpose of security reasons. As I mentioned, we do not want it's always better to follow the principle of least privilege, and this architecture supports that. So now that we have finished automating the work units, we also want to monitor them, right? Say, okay, NVD data came in, but there has been an error in the transformation, or there has been an error in the collection itself. Maybe you did not have data in the no new CVs have been published yesterday. You want to keep an eye on those, right? How do we monitor this? So now comes the automation, wherein we have the logging. Logging is the crucial component for monitoring, right? So you want to collect these logs. As I mentioned earlier, you can keep track the status of the work unit, whether it's completed or it's failed. So when you launch the spraying, say the CV data has some, the incoming file has some malformation. Maybe the network has an interruption and the data was not completely collected, and the JSON structure of the data was abruptly ended. So there was no end of the day, like you say, or maybe the data cannot be transformed in the expected format because the collection errored out some way, and there was a dirty file coming in. So to handle all those scenarios, when the work unit fails, you want to keep track of it. You can log it to the primary storage as a file again, or you can send it to the Azure table, or you can also send it to the Azure queue as a message. If it's Azure queue, as in the bottom box shows, you have an Azure monitor there, wherein you can keep an eye on the queue. If there is any exception or error message that has been sent to the queue, you can get alerted via email. Likewise, if it's an Azure table, you can also use you can also use Microsoft Fabric to pull the data out of the table and have alerts off of the report. Another third approach is, while the prior two approaches I mentioned, Azure Monitor, Microsoft Fabric, use of having just triggered getting an alert when an error message happened is different from being alerted with the actual message. Sorry. In case you want to know what the error message is, then you might want to use a cron job to read the messages, send the alerting emails, and then delete the message. That's another option. So as I mentioned, there is a way to use Fabric as well to get the alerts, right? Let's see why we want to combine our data with Fabric. So once the data is in primary storage, back in the primary storage of the transformation, you need to, as I mentioned, you need to find a way to visualize them, like get understanding of what is happening, make users of your employees of your organization or your teams to be aware of where these findings have been coming from, how to fix them, kind of like those. So here is where visualizations help, and Fabric really is providing great resources for visualizing. To start with, it gives a lake house. It's kind of like one lake house. Of course, why we want to use lake house when you have Azure files? We don't have to use lake house to be kind of like a primary storage. We want to use it to hold only the data that we want to report on. We might have an year old, we might have an year old of data. We might have historical trends running on maybe 3 months of data, but we don't need all that data in the reports, right? We keep some data to look into trends, to understand how we are fixing, how we are remediating, how the organization security posture is improving, stuff like that. But in the lake house, we might just keep the data that we need at that moment for the users to address. So it's kind of like a way to replace a SQL Server too. You no longer would need SQL Server because you are just using Lakehouse, and from Lakehouse you can just do the visualizations using Power BI. And then how do you get the data with the Lakehouse? Then Fabric offers ability to connect to your edge storages as well. You can connect to tables, or you can connect to the files shares that we just used earlier in the HPC storage as well, or even the primary storage. And you can connect to those primary storage, say, on the storage account. Then you can just create a pipeline and pull the data from the primary storage on a periodical basis, only on the latest data, and then use that data to reporting. And then the benefits of that is one, there is a way you can restrict access. Say you create a lakehouse with only the data pertaining to this week of vulnerabilities. And then the pipeline keeps on refreshing the past 7 days data every day. So it always keeps only the last 7 days data. And then you can use your AD or even a different way of access. Basically, you can control who can access the data, and then who can run the QQL or SQL queries on the data without the use of a SQL server. And then you can also have data activators, which help you to get alerted on new findings. So like, for instance, if there is a new vulnerability published by NVD yesterday, and you have the report ready, and today morning again the data has been collected and the new vulnerability has been reported, then you can create a data activator telling that, okay, if you see a new value here, please help me. And then you can have visualization, as I mentioned, from the Lakehouse data itself or from the Azure table connecting directly to primary storage. And the other feature is the Copilot, wherein you can search using NLP. You can search, like, for instance, okay, how many resources have been impacted by this vulnerability? Okay, what is the overall exploitability score of this resource for this vulnerability? Kind of like those. You can use Copilot, depends upon how advanced you want to go. But definitely the advanced NLP searches would require your help as well in order building that input feed. And then, of course, you can also use Copilot to build reports too.
So now that we have the transformed and clean data that Sowmya just told us about, let's figure out how we can ingest this data into Fabric. So I'm going to go over a small demo to show how we can ingest the NVDNS data into the Fabric source. So as soon as we open Fabric, we are redirected to this page. And here I have a workspace called the HPCC Summit 2024, just for this demo. As soon as you click on the new button on the top left corner, you will be prompted with a bunch of options. Make sure to select the More Options option here. And then you'll be redirected to the Fabric page. Here, make sure you choose the Lakehouse option. After you choose the Lakehouse option, you can give a name. In our case, we have chosen the NVD NIST as the name for the Lakehouse. And then make sure to hit on the Create button. And we now have a page where we can upload files, start with the sample data, or start with the new shortcut, new data flow, or new data pipeline. Since we already have the transformed and clean data, we choose the Upload Files options and are prompted to upload our files. I have then uploaded 5 files. These 5 files includes the NVDNS CVE weaknesses file, configurations, information, references, and metrics file. After we see the files uploaded, we can see them in this file folder. We have all of our 5 files all in CSV formats. We then click on the 3 ellipses next to the file and then find the Load to Tables options and then make sure to hit New Table. You can also click on Existing Table, but in our case, since we don't have an existing table, we make sure to choose the New Table option. We are then prompted to name the table. So I've just chosen the same name without any complications. And since my table has column headers, I have made sure to add those column headers. And since our table also is a CSV file, I have made sure to separate it with commas. And then I click on Load. And then in the top right corner, you can see the loading operation. And then you can finally see successfully created a pop-up box that opens up. And then we can see that our first table has now fallen under the table section. The same way, we continue to do that for all 4 tables. We now have all 5 of our tables in the table section in our lakehouse. This is a screenshot of just how the preview looks like. As you can see, we have a bunch of column headers, and then Fabric has the tendency to show about 1,000 rows. So that is what you see here. So now that we have ingested all of our data into Fabric, let's see how we can visualize this data. So to start off with visualization, our first step is to create a new semantic model. Once we hit on the new semantic model option, you're prompted to name the new semantic model. In our case, we've named it NVD NIST Semantic Model. We then get to choose our workspace. And as I mentioned previously, our workspace is HPCC Summit 2024. You are then prompted to choose the database. And in the database, you have the option to either choose tables or views. Since we have created tables, that is what we have chosen here. After you click on the confirm button, you are then redirected to a page where you can see all 5 tables in the form of relationship models. I would like to give some time here and notice that we have 2 options that we can move ahead with. You can either create a new report by building relationships between 2 or more tables, or you can auto-create a report that Fabric has an option of choosing. So I'm going to go over both of those examples, but let's go over the auto-create example first. So as you can see, there are no relationships with these tables. They're all separate and individual tables at the moment. So you can go back to your workspace, in our case, the HPCC Summit workspace, and then click on the 3 ellipses next to your semantic model that you've created and click on the Auto Create Report option. Once you've clicked that option, you are redirected to a page where you can see a prompt that says generating your report. You can also pre-select your data here, but I haven't done any of that, and I've just let Fabric take control. So once the data has, you can see the new graphs that Fabric has auto-created. You can also see the 5 tables here, but you can also notice that the graphs have only been built on 2 columns from a single table. This happens because there has been no relationships that Fabric has detected, even though there are, but that's where the manual effort comes in. If I want to choose more columns from the different tables, I can do so, but there still won't be any relationships between the graphs. They're going to be separate graphs only depicting what you've chosen with no relationship. Now, for some people, this may make sense, but if you want a much better understanding of what you want to visualize, the create a new report option where you manually design a report makes more sense. So let's go. So another thing that I forgot to mention is when you do have the auto create feature on, you can actually choose what kind of graphs you have. So if you click on this little paint button over here, you can also personalize the kind of graphs that you want. Again, this is a Fabric feature, and there's nothing really manually you can do to this. So now let me go through an example of how we can create a new report. Now let's go back to our main workspace, and let's click on the 3 ellipses again and choose on Create Report. Now we've been redirected back to the page where we have all of our individual tables with no relationships. Now to build relationships, we click on the Manage Relationship button in the top left part of the menu bar. And then you click on the New Relationship box. And now I want to build a relationship between the CVE metrics table and the CVE information table. And the common column that we have here is the CVE ID. I make sure to select both of those columns on both of these tables. I then choose a many-to-one cardinality and make this relationship active. Once I've made the relationship active, you can see that these 2 tables now have a relationship between them. So I go ahead and click on New Report. Once I click on new report, I can just see a blank report, but I can also see a filters pane, a visualization pane, and a data pane. The data pane consists of the 5 tables that I had, and then the visualization pane consists of all of the different types of visualizations I can use. And the filter panes is if I want to add a filter to the visualizations I end up creating. So for the first example, the visualization I've used here is a basic data table. You can see that the data table has 5 columns: CVE ID, base severity, published, last modified, and descriptions. But what you can also see is that I've got columns from the CVE information table and the severity column from the metrics table. And this happens because of the relationship that I created. So this table basically gives us a small bit of information about what the vulnerability is, which is the CVE, and how severe the vulnerability is, when it was published, when it was last modified, and a brief description of the vulnerability. I also have another example of a visualization. This is a donut chart. And as you can see, it's called CVEs by attack vector. What this means is that there are a number of CVEs that are easily exploitable via network, but there aren't that many CVEs that are exploitable via a physical source. This is a screenshot of the entire report that we created. So like I said, we have the data table, and then we have the donut chart to show the CVEs by attack vector. We also have a donut chart to show the CVEs by user interaction. What this is telling us is that there are so many CVEs that actually don't need any user interaction to be exploited versus how many need user interaction. And we also have 2 cards here that basically shows how many new CVEs were detected or were shown in the NVD-NIST database, and how many new CVEs were present in the last 30 days. Next, if you want to set alerts, if you want to get emails like the email alerting system for Fabric, we can do so by either clicking on the set alert option here or the small bell icon on your card that you want to set alerts for. In our case, I want to set alerts whenever there's a new CVE that's been found. So I click on the bell icon, and then you're prompted to this pane here, the set alert pane. The visual usually comes from whichever bell icon you've clicked. So since I have clicked it from this card, the visual that I have is the new CVE today's card. And then the operator I've chosen is changes. So if that number goes from 65 to 66 or 65 to 64, that's when I want to get the alert. So I have chosen the email option as of now. I have selected where the workspace is. And I've also given the item name, which basically is the subject line for the email. And then I hit on create, and every time there's a change, I'm going to receive an email.
So this single report, if you have seen, this is all generated from just that one day of NVD data. If you see what I mentioned earlier, like if you can relate, like you see there is user interaction information in the attack vector, what kind of attack vectors, like as you can see, as Kushi explained earlier, there are a lot of network-based attacks, right? So that is why you see orange in that donut chart on the left. But the bottom graph is where you get more information. It shows how the privileges required for an attack, or whether what is attack complexity that is involved in performing an attack. You can see that these exploitability scores, privileges required, user interaction, all these are additional features that you can get from just feeding off of that NVD data. Now imagine if you can combine this data to your organization vulnerabilities, how much richer information you get from that correlation. You will know, you'll be able to have your own risk assessments or understand the risk of your overall organization or a particular product or such thing. So we hope we have been able to give you some information on how you can use the NVD, and if it or not, this information has all been extracted using the HPCC server, and it just takes few seconds using HPCC. It's so fast. Thank you very much.
Thank you all.